we have previous recordings of similar sessions that I can point you to. So what do I actually need for my scientific goals as opposed to what do I want? We all want more telescope time, but you want to be very clear in your proposal what the minimum amount of hours needed are to accomplish your scientific goal. Like I said, we are oversubscribed, and we will do independent checks on your sensitivity to make sure that the time request seems appropriate. So we have a few different proposal categories. Here are two of them. Regular is sort of a few hours for projects that you expect to complete in a semester. And so you can see at this small range here, or at the low frequency, long wavelength range, a regular proposal can be up to 400 hours and under 1 year. As you start to get to higher frequencies, we have fewer of those hours available. And so the regular proposals drop down in the number of hours that you can have. I mentioned at high frequency, we tend to be oversubscribed. And part of that is that we just don't have the same number of hours available. We can basically observe at L-band almost all the time. Anytime the telescope isn't in maintenance or there isn't strong wind or ice accumulating on the dish, we can observe at L-band. At these higher frequencies, we need more specific weather conditions. It usually has to be very clear out, and you get those in the coldest days of winter typically. So those are regular proposals. Large proposals are anything that you can accomplish with more hours or are going to take more than a year to do. So a lot of the times our large proposals are going to be large surveys of the galaxy, whether that's for detecting new pulsars or trying to make large scale maps of either molecular gas or H1 or ionized hydrogen. We've had large proposals for all of those topics, and those usually take a lot more hours than you can fit in with a regular proposal and will be scheduled over many years. We've had projects that have been 5+ years on the telescope for some of these large surveys. And I mentioned we only now accept large proposals at one proposal call per year in the February deadline. Two other categories that we have are triggered proposals. And so triggered proposals are submitted at the normal proposal deadlines in August or in February. And these are intended for some pre-planned observations of transients whose times are not known beforehand. So you know that these are transient sources. You know that you want to observe them at some point, whether it's when they're flaring or when they have increased activity over the next semester, but you don't know when that flaring is. You can include these triggered proposals and they will not begin until you activate them. So you should have clear, well-justified triggering criteria. Say the flaring is above this fluence, and that's whenever you want to start your triggered proposal, for instance. Director's discretionary time, or DDT proposals, do not need to be submitted at the normal proposal deadline. These are sort of serendipitous proposals that you put in based on new discoveries, usually. So those would be target of opportunity DDT proposals. These are unexpected phenomena, and you want a really rapid response. So there were some DDT proposals when Oumuamua was coming through the solar system for the GBT to observe that. We've had DDT proposals for new fast radio bursts that were discovered, for instance. So you don't know these well in advance, and you want to be able to use the telescope as quickly as possible to make observations of that object. And we want to be able to enable that. So there are a certain number of hours every semester set aside for DDT proposals. I'm not sure how many hours that is, but that's at the discretion of, well, it's right in the name, it's at the discretion of our director, Karen O'Neill, and she will lean on the science staff sometimes to go through the feasibility of these proposals. So those don't go through a regular time allocation committee that's internal to Green Bank. And finally, for a DDT proposal type, you can have exploratory time. These are typically just a few hours or less that are intended to be a pilot project for something that you are going to then propose for in a future semester. So for instance, I put in a DDT last summer for some new types of continuum observing that we weren't sure whether we would be able to do with the GBT. We put in that DDT, got the time, proved that it was going to be possible, and then put in a larger proposal at the proposal deadline for many more hours. So those are just sort of pilot projects, again, so that they enable you to be able to submit a larger proposal later on. We do rank these proposals. Green Bank staff internally does not, but we have these time allocation committees and panels of scientists from across many disciplines called science review panels that go through the proposals and put in grade markings on them. And I think that's on the next page. So we do review between 300 and 500 proposals at every deadline. A few of them are going to be standout, maybe 10 or so. It's very clear that why haven't we done this before? This is an awesome project. This will definitely get scheduled. Again, very few are obviously poor. We're all intelligent, good writers, etc. We can package our ideas in great ways. And so it's this middle section, this middle, right, 450 or so proposals that any one of them could get scheduled on the telescope. They're all probably good ideas. And so how do you make your proposal stand out? Well, in my opinion, it's in large part about clarity to the review panels. And so here are some of the proposal elements that you are going to include in your proposal. First, the abstract, which will be on the cover page. This is going to be limited to 200 words for GBT proposals and a clear and concise statement about what your scientific project is as a first impression to the panelists is going to be important. You'll also have the chance for a 4-page scientific description. So that 4 pages includes the meat of your project. You'll want an introduction and some background information on your science, the project description, and everything else about the science justification for your work. The time request and technical justification does not count towards those 4 pages of science justification. And we have pre-formatted areas as part of the proposal submission tool that will guide you through what to put in for your time request and your technical justification. We'll show you that here pretty soon. So in your science justification, what should you do? Well, you should be thorough but concise and provide a relevant introduction to your science. As I mentioned, the panels are split up into scientific experts, but they are not likely going to be experts in your very specific domain. There is a section on the interstellar medium, there's a section on star formation, but even these small categories are very broad. There's a lot of research going on in each of those. So you do want to sort of lay everything out on the table and guide them through what your project will do. Include citations to relevant literature. discuss the potential impact of your successful proposal. How is this going to add to the field of pulsar astronomy or star formation if you detect what you expect to detect, but also include the potential impact of a null result. What sort of limits are you going to put if you don't detect these objects that you expect to? Things that you shouldn't do. Do not assume that all of your referees are going to be experts in your domain. I just mentioned that the panels are comprised to be fairly broad, so there should be some experts on your field, but you want everyone on the committee to be able to understand your science. Don't try to blind everyone with your science or with all of your technical jargon. Keep it simple when possible. And also, when a figure would suffice, don't use words to describe your project. Figures we've heard 1,000 times, and it's a cliche, but a figure is worth 1,000 words. They can help you save space and also break up your walls of text in your proposal. For the technical justification, what should you do? Well, make sure that you're up to date on instrumental availability and capabilities. This is where you're going to want to make sure that you read the proposal call. I would hate for you to put all of the work in to submit a proposal for an instrument that is not going to be up that semester. That's a way that your proposal will immediately get rejected, and you'll have to wait until the next semester or the next time that instrument is available to submit that proposal. You should also lean on observatory staff if you have any questions while preparing your proposal. I would suggest doing this as soon as you're able, because sometimes we will get a lot of requests right at the last minute, and we will try to accommodate that and make sure that everyone has a successful proposal in, but we will have a lot more time to do that if you do it as soon as possible. So what else should you do? Well, provide all of the information that is asked for. There are specific sections in the technical justification asking about RFI or new capabilities. You should put answers in for those. And if you don't know about RFI, let's say at W band, you can say that. We don't expect there to be harmful RFI at these frequencies. Just put in something there so that we know that you've thought through that problem. You should also use some of our observatory provided tools in preparing your technical justification. That includes our sensitivity calculator and the mapping calculator, which these don't just do the radiometer equation to figure out how much time you need based on your sensitivity. They will also take into account instrumental effects of the GBT. What is the expected weather that you might be scheduled in? What is your expected elevation of observations? Our tools add all of those into the calculation so that those aren't things that you have to worry about. You should also be explicit about any assumptions that you're making so we don't have to try to read your mind when going through the technical justification. Our science staff in Green Bank, several weeks after the proposals are submitted, go through every single one and try to recreate your sensitivity request. So the more information that you give us, the easier it is going to be for us to go through and confirm that sensitivity. Because we can also say, hey, we went through this. It doesn't look like they actually need this much time. They only need half the amount of time, we think, to accomplish their scientific goal. And so we recommend that you cut down the amount of hours that you allocate them if this proposal is successful. Hopefully, we won't have to do that. So just be explicit about any assumptions you're making and walk us through the steps that you took to confirm your sensitivity. Don't ask for things that are unavailable or impossible. If the proposal call says that the KU receiver is not going to be up, probably don't submit a proposal for that. You can ping one of our scientific staff and ask when the next time a specific receiver is going to be available, but submitting the proposal requesting it is not the time to do that. Do not ask for an instrumental setup that's not justified by your science. If your science requires the L-band receiver and you think that it would be nice to have other things in as well, or that you think you would like all of the possible bandwidth whenever you only actually need a small section of bandwidth for a certain spectral line, don't ask for that wide bandwidth range. In part because it's going to take up more space on our system and it's going to be harder for you to work with. So we recommend that your science guides your setup. Also, don't pad your time request for the same reason that I talked about being explicit with your assumptions. We would conduct an independent review to see how much time we think you actually need. So there can be quite generous suggestions for overhead. For instance, if you're using Argus, we recommend that your overhead is 100%. So you shouldn't be saying, well, I think maybe I need more than that. You should look at our guidelines for the overhead there. So some stylistic considerations: don't repeat the abstract in the proposal. It is included in the cover sheet. It will be one of the first things that any person reading your proposal is going to see. And if you include it in the abstract, you're just taking away valuable space. Or if you include your abstract in the scientific justification, you're just taking away valuable space that could be better served for your scientific case. The same goes for your technical justification. You do not need to include that in your science justification. That would count against your 4 pages there. Also, don't add content just to read the page limit. I imagine that any reviewer reading through your proposal is going to be perfectly happy to read a 3.5 page document as opposed to a 4-page document with some extra fluff put in. And you really should be following all formatting guidelines. Again, for a regular proposal, it's 4 pages. Also for triggered and DDT. And we bump up that page limit for large proposals, giving you 10 pages for those proposals that take a lot of hours or will be spread across multiple years. We also require a minimum of 11-point font, so it's legible, except for on figures and footnotes, but those should still be legible, and 1-inch margins around the page. So bottom line is, remember that referees read a lot of proposals, so make it easy to read, make it exciting for them. I've mentioned the August and February deadlines here a few times. The August deadline is reviewed in the months after August, and then that actual season begins in February and goes through July. So the proposals that are being observed right now with the GBT were submitted at the August deadline last year. Likewise, the February deadline, those observations begin in August and run through January. Some hidden gems for your proposals are that you can have joint proposals with Hubble, Fermi, Chandra, Swift, and Sophia. So this is a way for you to get time on 2 telescopes at once. There are some observers in this workshop now that had GBT time allocated from Sophia, for instance. So that TAC gets to say, yes, we want this observed on Sophia, and we are going to use some of our joint time to allocate them time on the GBT. So it's a way for, if you need multiple wavelengths, for you to ensure that you get those observations without having to go through separate time allocation committees, right? We have been in some talks with joint proposals for the James Webb Space Telescope, but there are no formal agreements between there right now. Another hidden gem, I think, is the idea of a filler time proposal. So these are proposals that can be scheduled in poorer weather or can be scheduled in small time blocks. Basically, anytime there's an odd gap in the schedule, you can have a filler time proposal that can be run that can fill that small gap. So you want things that have low overhead and are easy to observe. I would say in general, really high frequency receivers or projects are not going to be good filler time proposals. But if you have something that can be run at L band or 800 megahertz or at one of those lower frequency ranges, you should maybe consider a filler time proposal. These are good for things that would otherwise take many hours to complete. Some examples are, there are some chemistry surveys that have been added as filler time proposals. There have been surveys of the galactic plane looking at radio recombination lines that can be scheduled in marginal weather. And if it's a filler time proposal, you might get your project complete, even if you are, let's say, C ranked, because of how easy it is to fill into small blocks on the schedule. I've mentioned that we have a panel-based system with Greenbank and NRAO. It's actually a joint proposal submission system between both Greenbank and the National Radio Astronomy Observatory. There are 8 different panels, and we have broad community representation on these panels, but they do include some non-experts, which is why we would recommend that your science case be very clear throughout. So a grade of 0 is the best you can get, and a grade of 10 is the worst. And so in addition to those numerical grades, based on the number of proposals that are submitted in that given session and based on how much pressure we have or how much time we have available to schedule those projects, you will be given a letter grade. So a grade of A is going to be active for a full year, and you should expect that all of those observations are going to be complete. A grade of B is active for a semester, and you should get most of the time. A grade of C is 1 semester, and typically those are going to be scheduled as filler. Whenever there are no great, whenever it's hard to fill in an A project or a B project into the schedule, we will put a C project in. And then there's a grade of N for not accepted. This does not mean that your proposal was terrible. It means that we are not able to accommodate it at this time. I've been on proposals before that have been solid proposals, but the oversubscription was high enough at those high frequencies that it just wasn't in the top few proposals that could be scheduled for that semester. And so we've gotten N grades for those. There are also plus or minus grades occasionally associated with one of these, which give you an extra bump. So you might get a B plus or a B minus, for instance. If in doubt about what you should be doing, please feel free to contact us. And another tip is that in your technical justification, you have unlimited space. You should not worry about how much information you are putting into that technical justification. In fact, I would say that in most cases, the more information you can put into the technical justification, the better. So what are you using? How are you using it? How long do you need it for? And how did you determine those values? Please feel free to walk us through all of the steps that you used in determining your sensitivity. You'll be able to use that later on if you look back at this proposal, and it will help us to confirm that everything about your technical justification looks great. You should also include overhead time. So I have in here a breakdown of what we suggest for some overheads. At high frequency, instead of doing this calculation, as I mentioned, we typically just say multiply your time by 2 for Argus. You can be more granular, and specifically at lower frequencies, you're going to want to include, okay, I want to do a pointing every hour, let's say at C-band. And I expect that it's going to take me 15 minutes to do my initial pointing, focus, and setup. So you should include in that part of the technical justification what you used to determine your overhead time. Some common mistakes here that I might just point out: you should contact us if you are worried about them. One is a confusion limit, which once you hit the confusion limit, you are done unless you have knowledge of a mission at higher resolution. Most of these are the confusion limit and 1/f noise are not going to be common for most observers. But for the 1/f noise, this is receiver dependent, and it's relevant when the product of your bandwidth and your integration time exceeds certain limits. I had to worry about this for continuum observations. It's mostly relevant for continuum observations or when you have wide bandwidths. You can think of this sort of as gain variations. You also want to have a handle on what the RFI environment looks like. And we have some web pages that detail what the RFI should look like at specific bands. And I also suggest, again, that you use the GBT sensitivity calculator and our mapping calculator. And we're going to touch on that here in just a minute. So let's see. For when you're setting up your proposals, you will be able to set what are called sessions. So you should only include receivers and backends that should be observed at one time. So for instance, if you have a project that includes L-band, S-band, and C-band, one of your sessions should probably be L-band observations at a specific LST range. Another could be S-band observations, and another session could be C-band observations. This will maybe make more sense whenever you look through the actual proposal submission tool. The typical telescope scheduling period is going to be 3 to 6 hours long. And so you will very likely not be scheduled for a session that is 7 hours long. If you say you want 5 7-hour sessions, that's going to be hard for Tony to put on the schedule. And so it would be likely broken up into shorter sessions. So within a session, you should have them 3 to 6 hours long, and you should group sources that are close together on the sky. Your project is actually scheduled using the average array and deck of sources within a session. So you don't want to have one source that is on, let's say, at 12 hours and another that is at 18 hours. Well, the average of that is going to be 15 hours. Yep, 15 hours. And so you're going to be scheduled when 15 hours is really great to observe, but your one source is going to be setting very soon and the other has not yet risen. So again, just group your sources accordingly. Let's see. Also, don't restrict the observable LST range too much. The more flexibility that you have, the better chance you have to get scheduled. If you say you only want to be scheduled in this 3-hour LST range block, that's going to be hard for us to put on the schedule. If you need that, as in if your source is only going to be up for those 3 hours, okay. But in general, the more flexibility we can have to schedule you, the better chance you are going to have. So some other scheduling considerations. One is that I've mentioned a couple of times, the GBT is oversubscribed, particularly at higher frequencies and particularly when the galactic center is up. If your science demands that you observe when in those times that we are oversubscribed, that's fine. You can't do anything about that. But if you can, ask for some time that is going to be in lower demand. That would increase your chances of being scheduled. Another thing to point out is that fixed time projects are becoming harder to schedule with the GBT. This is because the GBT 10 years ago was at 100% or close to open skies time. That is 100% of the time was paid for by the National Science Foundation. And so we could basically have observations from proposals to fill up all of the GBT's time. Now we have several contracts that cut into that amount of open skies time. And so we are sitting at about 60% open skies, 40% from other contracts. Now, these contracts are often other science projects. So there's nanograv observations that look for pulsar timing for gravitational waves that buys some of that time. And there's breakthrough listen that buys some of that time. And so they're valuable projects, but they do make it harder for all of the open skies time to be scheduled. So this can especially impact pulsar and VLI or VLBI observing that require either really regular observations or observations at specific times. So if you do need fixed or windowed observations, you should provide a very strong justification for why you need scheduled at those specific times. Again, because it's being harder and harder to observe like that. And just be as flexible as possible with us. Make your must-haves very clear and different from your prefer to haves or would like to have for your science. So here are some important websites, links for all things related to GBT proposals, the primary portal for submitting your GBO and NRAO proposals, which I included that link earlier, and then the sensitivity calculator and mapping calculator. So I'm going to stop sharing this and quickly go through all of these things before the next session. So here we are on mynrio.edu. And this is where you would start to submit a new proposal. So I would recommend create a login name here. This portal is shared between Greenbank and the VLA for any proposal submission. You can click on the proposal tab here. And if you've submitted any proposals in the past, they would show up here. Let's submit a new proposal here. Let's say we're going to go for the GBT. You can see the other options are VLA, VLBA, and GMVA. So I'm going to create a new GBT proposal. And all of your options for going through the different proposal sections are here. You can edit your title page. I'm going to say Observer Workshop 2021. You can see there's regular, large, triggered, directed, or director's discretionary time, and you get to pick your scientific category. So my research is mostly in star formation. If you do have a proposal sponsor, you would select that here. For instance, Nanograv, West Virginia University, etc. In general, if this is a scientific project that you're working on your own, you would not put a sponsor in, right? And so I can save that. Let's see. My abstract's empty, it's yelling at me. Your science justification is just the PDF document that you upload. But your technical justification has all of these specific sections. So your science justification can only be 4 pages. Your technical justification, you can put as much text in these blocks as you want. There is no limit at all. And like I said, I think the more information in general, the better for us to be able to follow your train of thought. Let's see, what else is there? You can upload source lists here. You can say, okay, these are the resources that I need. This is like, I want to use L-band with this bandwidth, for instance. And then you create sessions. So these are what would actually be scheduled on the telescope. A session includes a specific source list and a specific resource. So I want to use L-band with these bandwidths to observe this set of sources. And so you would combine those into sessions and say that you want your session to be 4 hours long, for instance, repeated 3 times. If you do have questions about this, please feel free to contact us. We're very happy to help you through your proposal submission. Another one of those helpful links was this GBT Observers page. So from the GBT homepage, you can go to the Science tab, GBT Observers, and then it's just under Observing with the GBT. So on this page, let's see. Actually, yeah, just click that GBT Observers thing. On this page, there's information about proposing and about observing with the GBT. We have guides that run you through everything you should need to propose, and likewise, everything you should need to observe, including links here to the proposal submission tool, which we just went over, the sensitivity calculator and the mapping calculator. So I want to briefly demonstrate each of those. This sensitivity calculator, let's put in a random sensitivity. Let's say I want 10 millijansky sensitivity, and I'm going to be using the Vegas backend. That's our spectrometer and what we use for pulsar observing at L-band. I'll keep all of these other things the same. Whenever you go through here and click update results, it will tell you how much time you should expect to reach that sensitivity. And so our recommendation is that you just copy all of this information from here and put it in that sensitivity section of the proposal call. So you can see it doesn't necessarily look great there, but it's going to help us go through all of your sensitivity calculations. What else do we have? So that's a sensitivity calculator. You can also save this to a file. There are lots of options here for what you're doing, changing the rest frequency, changing your source declination, and what you want your minimum elevation to be, right? If you are observing at high frequencies, you probably don't want to be observing too close to the horizon, but if you're lower, you can maybe go down to 10 degrees or so. And if you are specifically mapping, then you are going to take the results that you get from this sensitivity calculator and put them in the mapping calculator. So this is going to tell you how much time it will take to do a raster map or a daisy map over some area of the sky. So let's say we are observing total power for a spectral line, and we want to do an on-the-fly rectangular map at L-band, and our integration time per beam from the sensitivity calculator was something like 97 seconds. I want this to be a 1 by 1 degree map, and I'm going to leave those other options at their default. If I click submit here, we again recommend that you basically copy and paste all of this information into the technical justification, but in the mapping part. And this will tell you how much time you're going to take for your total map. This also takes into consideration things about the telescope that you don't want to have to worry about. For instance, we can only accelerate the telescope a certain number of times per minute. If we take the telescope and move very quickly back and forth across an object, that's not safe for the instrumentation. We do not allow you to do that. And so the mapping calculator takes that into account. Another cool thing that this will give you is that it will actually give you the command that you can use in Astrid to observe your object. So if I were to copy and paste this command into Astrid, it would make that map that I just told it I wanted it to make. You can do that for either an RA long map or a declat map, scanning in the opposite direction. So those are all of the tools that I wanted to walk you through for this. And our next session is going to be any Q&A for final things that might be confusing to observers. But I'm happy to take any questions on any of those tools that I just described now. I think going through and playing with them is going to be the best way to get a handle on it. And like I said, if you do have any questions, we would be more than happy to help you go through the proposal submission. And so hearing no questions, I will